Hello everyone. This video today is going to be about the integration of a new component into a Syskit system and to show you a bit the workflow for that. So it's going to be modeling purely. So on the left you have my ideal editor, VIM, and on the right there's a Syskit IDE, which is a new development in Syskit. The component I have to integrate is a pose estimation component, more specifically an underwater pose estimator. This I didn't develop. I actually never ran it in my life. I don't know anything about it, so we're going to discover it together. So I'm going to open it here. That's the component interface. On the left you have the input ports, on the right the output ports. And for those that know that know rock, in the middle and this guy here show you that this component is using the transformer, and in the middle you have all the transformations that the component needs. So it needs a DVL to body transformation, GPS to body transformation, as well as the frame names. As I said, it's underwater pose estimator, so you can see on the left a bunch of inputs like standard sensors that you can find on the AUV. Orientation samples, so an IMU, then a pressure sensor that gives you depth. DVL is providing velocity to ground. Model velocity samples is the vehicle motion model, so it's giving you a speed estimate based on the thruster currents you give. LBL position samples. LBL is a sound-based localization method sensor. And GPS, well, okay, you know GPS. So now the first thing I'm going to do is actually create a composition which is going to bind different inputs of different types to the component to form a self-contained unit like subsystem. So the first thing is to create the composition, which I'm going to be very original about it. I'm going to call it pose estimation. So here you have a template generation, and it's creating a composition file and a test file. So let's have a look at the composition first. Going back to my editor. Here reloading. It's open here, and I can edit my file. Okay, I'm gonna remove the template here. There's like a lot of description of what stuff you can do, but since I'm going to tell you what you can do. So the first thing obviously is to add the pose estimator itself to the composition. Pose estimator. Yeah, it's pose estimation. What pose estimator as gen estimator. I have to give it a name. And to be able to use it, I'd have to tell Syskit to load the pose estimation origin project. It's going to be our first child here, first child. Of course, the whole point here is to show reports, is to provide inputs for all that stuff here. So as I said, it's going to be a generic composition because I need to be able to deploy it both in simulation and in the real system. So here I'm going to use data services, and I'm going to add one child per type of sensor. So first orientation samples, that's a fairly standard service. Then the depth samples. That's actually, there is also a service, but I forgot the name. That provider. Then DVL. I'm not sure there is actually a DVL. Let's go velocity or no. There's no DVL service. So let's forget the DVL for now. I'm gonna add it later. I'm gonna leave out the motion model also for now. So let's go to the LBL, which is providing position. Then the GPS, which is also providing position. And okay, well then, and let's connect all that stuff. since their services are very simple, they have only one output usually. All of them only have one output. So to connect, I don't really have to care about the port name. I can just automatically just say connect that child to the port of the other child. If there was an ambiguity, Syskit would fail and tell me there is an ambiguity. So you can use this kind of like not specified port only if it's very explicit. So only if there's only one possibility. Orientation samples port. Then depth child, depth samples port, LBL child, LBL position samples port, and GPS is GPS position sample port. Let's reload that and see if everything is okay here. Yeah, so we have our children here and they're all connecting to what needs to be connected. Okay, that's fairly simple. The next thing is that obviously our pose estimation subsystem is also a pose provider. So we're gonna task Syskit that it's providing a pose, and we also have to give it a name. And for that to happen, I have to tell him, give him some ports. And this is done by exporting children ports. So finally reloading one more time. Here, okay, I have a pose samples. And my composition provides a pose, and because it's providing the pose, it's also providing a bunch of other services. So like the pose provider is providing a notation, position, a depth, and a notation with depth. Okay, so that's all for the generic composition, but now obviously we'll want to run it somehow. No, wait. I forgot one thing, the LBL. Not the LBL, the DVL, sorry. The DVL doesn't have an input. Okay, so as I said, the problem here is that Syskit does not have, well, the bundles don't have a model for velocity providers. So we'll create one into our own bundle and then add it also to the main bundle and migrate to it later on. So here, obviously we'll commit velocity. Here you don't have tests, really no unit test for velocity, and reload. So look at our velocity provider. Yeah, it's nothing right now, but we'll edit it. In rock, all the rigid body state information is in the rigid body state type, and I have to load the type. So what the comment here says is that I have to load the relevant type kit to get the rigid body state type, and that's defined by the base type kit. So here I have my service done. Yeah, velocity samples, blah blah blah, and now I need to add it to my pose estimation composition here. So I'll just put it in the same order than the ports. It's pretty practical. Velocity as velocity. And here it's going to be a TVL sample sports, and I have to load the velocity size definition. Okay, reload that. It's not rock size, it's velocity. It's flat fish services velocity. Okay, reload it one more time. And I got it wrong here. Wait, but DVL samples for child estimator does not exist. For DVL, yes, DVL velocity samples. And to match the other children, we call it DVL velocity. Okay, reload models. Okay, this one loads. We finally have our DVL here. Well, that's going to be all for the composition. One last thing is obviously documentation. Integration of the underwater here. Generate integration. Mirror. And if you reload, it's actually going to appear here. Okay, next step is to actually get it to deploy, and that is done in Syskit, it's done in profiles. Let's have a look at the profiles. There's two of them here, base and stable pitch roll. It's part of the base system, the pose estimation, obviously, so I'm going to edit the base profile. I'm skipping all of that and just define pose estimator. Pose estimation, and here I obviously have to tell him what to use, and I won't get into too much detail, but this is the device that represents the flatfish model in our simulation, so in the gazebo. So it's basically the robot model, and this robot model has a position and velocity outputs. I just reloaded the models. I like to take into account my changes, and I'm going to deploy the pose estimator. And this time there's an error, so it says cannot find a concrete implementation from one task, which is the there's no candidates and it's a child DVL of the composition. And indeed, you can see the DVL child is still in red, so it's still an abstract thing. It's not didn't pick up this flatfish depth for it. When you think about it, it's pretty obvious since we just created that service. The device model here and the component model can't provide that. Here you see that I'm actually saying use flatfish device. So what I have to modify is not the model task, which is the actual component. It's one more layer, it's a device model. Syskit makes a difference between something that just processing data and something that actually has a interaction with the outside world, the world being in this case just the software. So what I have to modify here is the ROC device's gazebo model device, because that's what I'm selecting in my profile. ROC device's gazebo model here, which provides a lot of stuff. So it's actually allowing to control the joints of the gazebo model, and it's providing a pose, and now we want to make it provide velocity. Here I'm going to do a little hack. I'm going to tune the definition of that device so that in this bundle it provides velocity. Obviously the right fix is to move the velocity service into the ROC bundle and do all the definitions properly, but for the purpose of this demonstration, I'm going to do the hacky way. So I need my service. I need to require the device model, so it's models. Then I should tell Syskit that one is provided by the other. This is velocity. And how are their ports related? So what I'm doing here is tell Syskit that the pose samples that is already part of this ROC device's gazebo model, and the velocity samples of the service should be mapped to the pose samples of that. So let's and one very important thing is to not forget to load the existing file. Otherwise, we won't get the original. Okay, here. Where are we done for that? Flat fish profiles gazebo base, and let's have a look at this. Different error this time. Could not find a frame assignment for RMU. Okay, I'll just show what this means. Here, better do that. I need to show transformations. Here it means that I'm in a system where, as I said, the water pulse estimator is using the transformer. And now I obviously have to tell him about all the frames. So what's the GPS frame, the LBL frame, and everything. On the device side, it's already done because these frames are generated from the SDF file. So I know that this pose is the flatfish to world. But obviously on the water pulse estimator, I don't know. But I'm going to stop here for today. In the next installment, I'm going to talk about the transformer, then we'll go on with deployment and runtime.